Hi everyone, today we're going to look at how to insert a data item into a linked list. The linked list is being implemented on a one-dimensional array, so we will be using the benefit of array indexes, which is very useful, of course. Let's remember that this is a linked list of nodes, and each node has a previous pointer, a next pointer, and a data item. You can see in this example that we have 8 nodes, and some of them have already been populated with data. This one stores 14, this one stores 19, this one stores 24, this one stores 37, this one stores 61, and these 3 nodes don't have any data in them yet. They've got their pointers set up, and hopefully you know how to set up a linked list of nodes and each node having the correct pointer. In fact, instead of using a slash there, I'm just going to put in what I was using with my own students in class. Just going to change that to -1 because that's the end of the list in its current form. Now you can see that we have a root pointer which points to the first node in the list, which is currently at index 0. And I'm also creating another pointer called search pointer. This pointer is going to help me iterate through the list. So I'm going to jump to here, and I'm going to jump to here, and I'm going to jump to here, and I'm going to jump to here, etc., etc. Why aren't I using root pointer to do that? Well, it's good practice to leave the root pointer alone. It always references the start of the linked list. Just leave it. Even if you're not going to be using it for any purpose, I recommend that you just leave the root pointer alone. It always references the start of the linked list. Create another pointer to do any searching. We also have an interesting pointer here called free pointer, and you can see that free pointer references the first available free node that doesn't have any data in it yet. Okay, that's going to be useful for us because what we're going to do, we're going to push a new item of data into the node referenced by free pointer. That's what we're going to do. Oh, okay, we've done it. Brilliant. Now what we need to do now is figure out the new links. Because as you can see, this linked list is organized in ascending order of data item value. 14, 19, 24, 37, 61, it's all in ascending order. So when I put 29 there, I've kind of messed everything up. So I need to relink the nodes to keep the order. So let's think about how to do that. We're going to use our search pointer to search from the root through the list to see if we can find the appropriate position for this value 29. What we're going to do is ask, is 14 greater than 29? Well, no, it's not. So we're going to update the search pointer. Is 19 greater than this new value 29? Nope. So we're going to update the search pointer. Is 24 greater than 29? No, it's not. We're going to update the search pointer. Is 37 greater than 29? Yes, it is. So we've got part of the story here. We know that we're going to insert this item between nodes 2 and 3. Search pointer is going to store the address of this node. The value is 3. We also really need to store the value of this address. Okay, so a classic way of doing that is as you're looping through the list trying to find the appropriate insert position like we just did, we also need to store the value of the previous pointer. That will be very useful, and I'll explain why in a moment. So that loop has resulted in a search pointer value of 3 and a previous pointer value of 2. So now we need to update some pointers. Now let's just think about what we're doing here. our linked list goes in ascending order of value: 14, 19, 24, 29. So this is the new link. This goes here. And then from 29, we're going back to 37. So we need to update a few of the pointer values in the nodes. The node referenced by my previous pointer no longer links to 3. It now links to the value referenced by free pointer. That is this 5. So we're going to use that data to update this one. That now goes to 5. So that link disappears. And the next value of this node, which is referenced by free pointer, is actually the node referenced by search pointer. So this isn't 6 anymore. It's the value referenced by search pointer, which is 3. So we've managed to successfully relink the linked list in order to keep the order. And then finally, what we have to do is update the free pointer. Now when we do that in the algorithm, might be a little tricky. We're going to look at how to do that as we figure this out. So if you're not sure what I've just been talking about, if I were you, I would stop the video now, just rewind, go back to the beginning, look at it again, because now we're going to look at how to build this algorithm. Okay, let's look at how to build the algorithm. First of all, I'm going to set my search pointer to be the same as my root pointer. Okay. I'm also going to look into my list, and I'm going to go to the free pointer element or node, and I'm going to assign its data item to be the new item. Okay. Do you remember me doing that before? I took the item. Whoops. I took that item and I assigned it to be the data item within the free pointer node, because before, of course, at the very beginning of this was the free pointer. Okay? So that's what I'm doing there. Now what I'm going to do is loop through the list. So while list search pointer dot data item is less than the item that we're trying to insert, I'm going to save the current node that we're at. What did I call it? Did I call it my prev pointer? My prev pointer. I'm going to save that one because we'll need it. And we need to update the search pointer. Okay, so search pointer equals list search pointer dot next pointer. Now that line of code looks a little bit scary, but let's just have a quick look at how that works. Let's hide some of this stuff. Do you remember the search pointer initially was here? And we said while list search pointer's data item is less than the new item, well that's true. Search pointer's new value is going to be list search pointer, that's list 0, list search pointer dot next. next pointer. List search pointer dot next pointer. It's 1. So search pointer has now been updated to the value of 1. So then we go back into the while loop, while list 1 dot data item. So search pointer is now 1. 19 is less than 29. So search pointer equals list search pointer dot next pointer, which is 2. So this becomes 2. Do you see how that works? And we're also storing the previous value before the update. And by doing that, we should be able to store the previous pointer. So when search pointer was 0, my previous pointer becomes 0 and search pointer becomes 1. And then when search pointer becomes 2, my previous pointer becomes the original value of search pointer, which was 1. Does that make sense? Okay, so they're basically following each other up the linked list. Sorry, I keep switching to that. I don't mean to. Now then, so that's what the while loop is doing. So by the time we finish this loop, the search point, these 2 pointers will be the pointers we need for the insert. Now, let's just remember what we were doing. So we've reached this scenario. Search pointer is 3 and my prev pointer is 2. We now just need to update our links. So list free pointer dot next pointer is going to be assigned the value of search pointer. And list my prev pointer dot next pointer will be assigned the value of free pointer. So we've done those 2 updates. List free pointer dot next pointer is assigned this value, the search pointer value, and list my prev pointer dot next is assigned the free pointer value. And then all we have to do is update free pointer. I'm not sure if we can do that because I just changed next. How can we do that? Free pointer, because it should now be 6, shouldn't it? Where do we get the 6 from? I've just overwritten the 6. I made it 3. See if you can figure that out. Somewhere in the algorithm I've messed up a little bit, but I hope this video was helpful and it will help you to understand how to insert an item into an ordered linked list.